Hello Calculus and welcome to 9.6. This is the last section in this chapter and this is double integrals is what we're doing. So just like you do double derivatives, you can do the same with integrals. We will do up to 2. We will not be doing 3. We will do it over variable regions and have a little bit of fun with it. So we're going to do a definite and then a double and the double integral over a variable region. Now let's go here. To evaluate a definite integral, you find the antiderivative, you substitute the upper and lower bounds like before and subtract the two. So let's show you how this works. I want to go 5x cubed y to the fourth minus 6x squared y plus 2 dy. So I'm telling you which one I want to do the antiderivative of from 2 to 1. Nothing different than we've done before, actually. So now we're going to look at this first one. I want to do the antiderivative with respect to y. So you just add and divide by 5. So I get x cubed y to the fifth minus this one. So x squared y squared divided by 2 gives us the 3 plus the single number turns into my dy. Plug in the 2 to your first part plus you still have your constant of x minus plug in the 1 and you still have the constant of x. But the constants of x's will always cancel. And this will always happen, so we never ever have to really and truly include them ever again. It won't be points on your test. Combine your like terms and you are finished. Okay, pause and try yours. Be careful what I ask you to find the antiderivative with respect to. This time it was y again. So your antiderivative with respect to y should have been 2x squared y plus 2 y cubed. I forgot my cube. 2xy squared plus 8x cubed y plus you're dividing by 5, so that's a 2y to the fifth plus 3y. I hope you did well. All evaluated from 2 to 1. So we plug in the 2 first and then subtract the 1. So let's go here. I hopefully have enough room. So you're plugging in the 2 for the y. So this is 2 x squared times 2 cubed plus 2x times 2 squared plus 8x cubed times 2 plus 2 times 2 to the fifth plus 2 times 3 minus, now you're subtracting the 1 value. So you've got 2x squared minus 2x, since 1 to any power is 1, minus 8x minus 2 minus 3. All right, I hope you did a good job. Combine your like terms. So here we should have 16x squared minus 2x squared, which is going to give me 14x squared. Right here we have 8x. Do I have any more x's? Minus 2x. It's going to give me a plus 6x. So this is done. X's are done. 8x cubed times 2, so that's 16x cubed. I have no x cubed, so let's write him in front, so we have descending order. All right, here we have 2 times 32, which is 64, plus 6, minus 5, so plus 6 d5. I think I did my math right there. All right, if you have any questions, let me know. All right, evaluating definite double integrals means you have to do the first one, the inside, outside, just like before. So the first thing we do is we do this with respect to x, all from 5 to 3. So with respect to x, so that's going to give us 3x squared y squared. This is going to give us, divide by 3, 4x cubed y plus 4xy, all from 5 to 3. So we plug in the 5. we plug in the 3, and we simplify. So this is the simplified version of that. Then we do it all again with respect to y. So we 3 and divide, so 48y squared, so 5 divided by, oh, hang on, I lied. We got to combine terms first. And then this one, and this one, and this one, and this one go together. There we go. Now we're completely simplified. Now let's do our derivative. So 3, so 16y cubed, squared divided by 2 is 200y squared, all from 2 to 1. Plug it in, and we have 712. Okay, exact same problem, but now we're going to do dy then dx. Let's see what happens. So pause and make sure you take your time. So your first step is you should have done this with respect to y. So 3, so this was 2x y cubed plus 6x squared y squared plus 2y squared. All done from 1 to 2. So let's plug in the 2. 2 for y. So 2 cubed, 8 times 2 is 16x. 2 for y, 4 times 6 is 24x squared plus 8. I hope we did well. Minus, now let's subtract the 1. So we got minus 2x minus 6x squared minus 2. Let's combine our like terms here in descending order. That's going to give us 18x squared. What else do we have here? Plus 14x plus 6. Now we have to do the integral again from 3 to 5 with respect to x. So now we're going to get 18 divided by 3, 6x cubed plus 7x squared plus 6x, all from 5 to 3. Plug in your 5. Whoops, 7. Sorry about that. Plus 6 times 5 minus, plug in your 3. Don't forget you're subtracting all the way through. Plug that into your calculator. I got 712. Did you notice they are the exact same number? It does not matter which order you integrate as long as you keep your integrals with each other. So this here has to go with the y. This one has to go with the x. All right, and that's what that rule says right there, is that you are allowed to do that. Okay, this is just saying it's a rectangular region from x to y. You can do them in any order as long as you keep your integrals the same. Everything that we just actually proved. So now let's look at our, whoops, that was weird, sorry about that. Okay, so now let's look at our rectangular region. That's all the R means. This is the function that we are going to evaluate. We're going to have dx and then dy. It says x is between 0 and 5, y is between 1 and 6. This gives us our integrals. So when we set up our integral, we have our function. If I do x first, then I do 0 to 5, then y is 1 to 6. You could have reversed that. It would make no difference. You rewrite them with the correct exponent to the negative 1/2. You do the derivative or the antiderivative. Now when you're doing this, you're adding the 1 and dividing, which makes it multiplication by 2, times the derivative of the inside. Remember that u du part? So now, but the derivative of x is 1, and I have 1 dx. So I can do this. I don't have to do, or my integration by parts is working, because I have x here, and then I would need 1 dx, which I have, because a 1 is assumed. So we can move. We plug in the 0 to 5, 5 to 0 I mean, type in the 5, put in the 0, do your multiplication, and we're down to here. So now we have to do this again with respect to y. So now we do 1/2 So we'll add 1/2. You got 3/2, so you're multiplying by 2/3, which gives you the 4/3. Y plus 8 to the 3/2. Again, the dy is 1. So we're good. I can do this. The same thing over here. Again, the dy is 1. We're good. Plug in 6 to 1. Your 6 goes here. 6 plus 8 is 14. 6 plus 3 is 9. Plug in your 1. 1 plus 8 is 9. 1 plus 3 is 4. Put it into your calculator, and this is really ugly answer, which is fine. Or you can use the decimal. I just don't know what that is off the top of my head. Okay, now let's go when it doesn't work so pretty. So we've got, come on, it froze. I think we're back. Hopefully we're back. So now let's see if this will move. Sorry about that. Here we go. We have the rectangular region. We're going from 0 to 4 and 0 to y. But there's things we got to remember. This one we have to remember that the derivative of 1 over u is the natural log of u. None of this goes away, or your antiderivative. So we are going to do the integral, and I just chose to do x first. There was no reason behind that. So the y goes from 0 to 2. The x goes from 0 to 4. We are doing 3x, I'm going to write it to the right power, to the 1/2 y, all over y squared plus 1, and I chose dx then dy. You could have done it the other way too. Now, when you do your antiderivative with respect to x, so we're worried about this guy only, the denominator is unimportant because he doesn't have an x in him. So this just becomes, so 3 multiplied by 2/3 is just 2. So you got 2x to the 3/2 y all over y squared plus 1, all from 0 to 4. When you plug in, well, the 0 makes it 0, so you plug in the 4 here, the cube root of 4 square root, the 4 cubed, and then the square root, or the square root of 4 and then cubed. So that's 8 times 2, which is 16. Y over y squared plus 1 is the first step. So now I'm going to rewrite this up so you can understand what's going on. We're going from 0 to 2. We're going to do 16y times y squared plus 1 to the negative 1 dy. Now, in order to do this, remember you're inside, so if u equals y squared plus 1, then du has to equal 2y. Okay, I'm going to pull the 16 out because I don't care about him. All right, so I've got a y here, and I need to put it with the dy. Okay, I'm hoping you're remembering what we just did. Plus 1 to the negative 1. Then I'm going to need, I have a y and a dy here. I need a 2 because it's got to match. So I put the 2 here, but if I put a 2 here, I must divide by 2 on the outside. So now that I have my dy set, I am allowed to integrate. Now, this is where the natural log comes in. So we know 8 is what's on the outside. So we just write him down. It came from 16 divided by 2. It's the natural log of y squared plus 1. All right, all from 0 to 2. So plug in your 2, and you get 8 times the natural log of 5 minus 8 times the natural log of 1. Well, the natural log of 1 is 0, so this goes away. 8 natural log of 5, when you type it in your calculator, is roughly 12.88. Okay, I hope you did well on that. There was a lot to do on that problem. Okay, volume. Now this is a function, it's never negative. Remember that, it has to be positive over a rectangular region again. And again, we're looking at the area or the volume of weird different shapes in here. Look at, doesn't this look like fun? We got surface area of x squared plus y squared. Here my surface z is just a function, and this is how y and x change. So let's go and see what we can figure out from these things. I want to find the volume under x squared plus y squared. So remember, that's my circular shape. When 0 to 4 for x, 0 to 4 for y. So we do x squared plus y squared. I did with respect to x then y. Again, it makes no difference. With respect to x, we got x cubed over 3, xy squared. We plug in our 4 and our 0. The 0 literally gives us 0 since it's all multiplication, so we can ignore him. 4 cubed over 3 plus 4y squared. Derivative again with respect to y. I simplified this first, but with respect to y is 64y over 3, 4y cubed over 3, from 4 to 0, plug it in, and your answer is 512 over 3. Okay, pause and try yours. Again, both of them are going from 0 to 1. Our equation is 4 minus x cubed minus y cubed. And I chose dx again. I don't know why I always do, but that's the one I like to do first. So we got the 0 to 1 for the derivative of y. We do the derivative of these, so we are going to get 4x minus x to the 4th over 4 minus y cubed x, all from 0 to 1. So when we plug in the 1, we're going to get 4 minus 1/4 minus y cubed, which equals 15/4 minus y cubed. 0 is going to give me 0 since all 3 of those have an x in them. So next, we're going to go 0 to 1, 15 over 4 minus y cubed dy. Do your antiderivative. So we got 15y over 4 minus y to the 4th over 4, all from 1 to 0. Plug in your 1, we have 15/4 minus 1/4, plug in 0 and you get 0. So that's the end of it, which is 14/4 or 7/2 or 3.5, whatever you prefer. I hope you did well with that one. That one wasn't too bad. Okay, next. This is a long one. I apologize. Come on. All right, we want to find the volume of this shape. It's a perfume bottle. Now the volume of a perfume bottle is the base is 4 centimeters, 3 centimeters, and they gave us the cross section of the interior is given by z equals minus y squared plus 4y. It doesn't really matter which one you choose to integrate first because one is not easier over the other. So guess which I'm going to do? dx, of course. 0 to 4, 0 to 3, because that's what they said they went by. Our equation is negative y squared plus 4y. I'm doing dx, then dy. Literally, because I've only got an x to each of them, so it makes life kind of easy. So this is minus xy cubed plus 4xy, all from 0 to 3. Plug in 3, we get minus 3y cubed plus 12y. Plug in 0 and you have nothing. I wrote that down wrong. That's supposed to be a square. I thought it looked a little funny for area. Let's fix this real quick. Maybe. There it goes. I apologize. Squared, squared, and squared. So now you're doing the second integral from 0 to 4, a negative 3y squared plus 12y dy. Your integral is going to be, so you're going to divide by 3, so it's just minus y cubed. Divide by 2 plus 6y squared all from 0 to 4. Your 0 again is going to give you 0. So we're going to have minus 4 cubed plus 6 times 4 squared. Type that in your calculator and you get 32 centimeters cubed. I hope you did a good job. If you did it the other direction, you should have gotten the exact same answer. All right, double integrals over variable regions. So this just means that your region is changing. It's not pretty and solid, so we got all these wiggles to worry about. So we're going to have the first function, we're going to go from a to b, and it's a function over a function. Or if it's going the other direction, with the x first, or the y has the values, and the y's are on the outside, and the functions are on the inside. So you evaluate whoever is between functions first, whichever way that may be. So when you look at the equation, here, x is between a and b, so he is last because y is between functions. They go up and down. Here, the y is between solid lines, so the y is last, and the x is between functions, so the x is first. Just depends on how you can write the equation. All right, so we're going to look here. I want to evaluate x, y, dx, dy. Find the area bounded by x equals y, so x is between a function and x equals y squared. So since x is between the functions, we're going to evaluate him first. Bounded by y is 1 and 2, so since y is numbers, he is second. It's just the way it works. The equation we're evaluating is xy. So you go xy dx dy. I have to do with respect to x first. So it's x squared over 2y. Plugged in your y squared and your y. So nothing different on your differentiation are your antiderivatives. After you've done that, now you do this with respect to y. So you do your antiderivative again from 1 to 2, and that is when you find your actual area. Okay, pause and try yours. Okay, when you're looking at this one here, I hope you did well. It was a little bit tricky. So we got x plus 2y dy dx is what I want to evaluate. Well, when you look at you have to look at the graph to figure this out. It goes from 2 to 4. Well, I can do, when you look here, it says y equals. So since y has the functions, y is the one we evaluate first. So we're going to go like this, and y is going to go from x squared on the bottom, because he's smaller than the x, is how that should go. And we're going to do x plus 2y. So I have to do this with respect to y first and then with respect to x. Well, x is going from 0 to 2. So I evaluate x from 0 to 2 in my thing. All right, now it's just your antiderivatives. So we're going to do the derivative with respect to y. So we got xy plus y squared, because you divided by 2, all from, I forgot my 2x up here, I apologize, all from 2x to x squared. So we plug those in, so we'll have 2x squared plus squared 2x, which is going to be 4x squared, minus, plug in your x squared, so I'm going to have x cubed minus x to the 4th. All right, let's put all that in descending order. So now I've got a negative x to the 4th, a negative x cubed plus 6x squared dx. Do that antiderivative. Did I write the 2 or did it just go funky? Sometimes I don't think this computer likes me. There we go. Okay, let's do our antiderivative. So we're moving this direction. So I've got negative x to the 5th over 5 minus x to the 4th over 4, dividing by 3, so we got plus 2x cubed, all from 0 to 2. Plug in 0, you're going to get 0, so your 2 is negative 2 to the 5th over, I think I wrote a 5 instead of a 4. What is going on with me today? Over 5 minus 2 to the 4th over 4 plus 2 times 2 cubed. Plug that in your calculator and you get 28/5. All right, I hope you did a good job. That was a little bit harder than the one we had to start with. Okay, next. Since the shaded area is between the area where the two functions intersect, you can solve the function for x and evaluate with respect to x first. I don't think you'd ever want to do that because when you're solving for x, so your y equals 2x is going to be x equals y over 2. And your other one you had to solve was y equals x squared, which means x equals the square root of y. So when you would do it that way, now y goes from 0 to 4 because you're reading the y value. X is going to go from the square root of y to y over 2. I'm hoping you understand why this is not near as much fun. X plus 2y. Now you're doing it with respect to x and then with respect to y. Okay, pause and give it a shot. Let's see how you do with this thing. So you got x squared over 2 plus 2yx, all from y over 2 to the square root of y. Plug that in, and you would have gotten hang on. Okay, I forgot to tell you something, and that's totally my fault. When you're reading the y value, you have to read from the left to the right. So this doesn't go in that direction. When you type this in, since the first one you're going to hit is the y over 2, that is the one that needs to go in the denominator. And the one that goes up here then is the square root of y. There, that's much better. Squared y over 2. All right, plug in your square root. Well, the first one, that's pretty easy. Y over 2 plus, now you're going to plug in the square root here, so that's to the 1/2. So 1 plus 1/2 is 2y to the 3/2 power, is where that came from. Subtract, now plug in your y over 2. So you can have y squared over 4 all over 2, so that's y squared over 8 minus y over 2. So the 2's a cancel, and you should just have a y squared. All right, you have to evaluate, plug in or combine your like terms. So we've got these two go together, and that's about it. So now we have to evaluate from 0 to 4 of y over 2 plus 2y to the 3/2 minus 9y squared over 8 dy. Sorry, this one's so long. Okay, do your antiderivative. Y squared over 4 plus 4y to the 5/2 over 5 minus 3y squared over 8, all from 0 to 4. Again, the 0 will give you nothing. The 4 is going to give you 4 plus 4 times 2 to the 5th over 5. I reduced this one is what happened here. Minus 3, 4 squared over 8. And your final answer is again 28/5. All right, good luck with your homework. Post questions if you have any.